we are going to talk about the basics of deep learning. Basics as in we will first understand what is machine learning, what is deep learning, and why we're talking about it now. So this is basically an introductory session. Most of it, what we have discussed here, has been discussed earlier as well in these sessions. So if you are new to the machine learning or deep learning, you will find it very useful. We will learn about categorization, classification. We will learn about various kinds of machine learning, and we will also learn a bit about deep learning. All right. So feel free to ask questions using Q&A window, and to respond, use the chat. All right. That's the common mode of operations. All right. So right now, quite a few learners have joined. Around 108 attendees are here in the session. So, and there are going to be quite a few questions. So please be clear in the question, and please try to avoid the chat language. All right. Great to have all of you in the session. All right. So feel free to ask questions using Q&A window, and to respond, use the chat. This session is going to be 3 hours. Okay. There's going to be a 10 minutes break in the midway. And if you have more questions related to career and so on, please feel free to ask here or on our forum. Wonderful. So let me give a brief introduction about ourselves and what we're going to cover today. So at CloudX Lab, we're making learning fun and for life. And by the way of videos, by the way of quizzes, by the way of hands-on, by the way of projects, and by the way of case studies. And also at the same time, I am all right. So at the same time, we have launched a product called BootML that helps people get started with machine learning very quickly. So that's the another addition to what we have here for making learning fun and for life. All right. So we'll talk about BootML briefly towards the end. All right. So all right. So at CloudX Lab, we are making learning fun using videos, quizzes, hands-on projects, case studies, and all of it based on the real life use cases. All right. So one of the things that we have created is called automated hands-on assessment, which is basically for learning by doing. Right. So in automated hands-on assessment, you get a problem statement and you have you do the hands-on, and then it gets assessed by a system automatically. All right. So on one hand, you have, let's say, the problem statement here, and it is asking you to log in. And once you log in, it will check and quickly verify. At the same time, we have also created a Jupyter-based evaluation. There's a Jupyter notebook. And on the left-hand side, it is asking you to define something. And on the right-hand side, you are given a notebook, and you can basically evaluate there. And then you can click on I'm done and so on. All right. So if you are new to CloudX Lab, please feel free to explore. And most of our stuff is available for free as a free trial, and then you can use it. All right. Okay. Great. Wonderful to have a great audience. Now, this is something that we have created, and you can take a look at this by going to My Courses, going to Python, and try using it. Okay, or even on the main homepage at CloudX Lab, you can click on Python course and then get started. All right. To experience it, you can use CloudX Lab. All right. So this basically makes learning fun. On the left hand side, you have a challenge. On the right hand side, you have a notebook. Notebook is not uh, a notebook is not a toy application. Notebook is a full-fledged machine learning workbench whereby you can do everything. Okay. So this course, today what we're discussing is it is the first session of our course. Okay. The course is deep learning with TensorFlow. All right. So we are going to learn deep learning with TensorFlow as part of this course. Okay. So let me make it full screen again. All right. So the course objective is deep learning with TensorFlow. And today we are here. We are at Introduction to Deep Learning. After this, the next session is going to be next Saturday. Um, and then we will be discussing, we will get up and running with TensorFlow. And please note that one session here does not mean one day. Okay. Our one day's session is going to be 3 hours. So the second chapter might take two sessions and so on. This might take 3 sessions. This might take 3 sessions or so on. So here we are starting with the introduction to deep learning. Afterwards, we are going to be up and running with TensorFlow. We will understand how the lazy evaluation work because there has been a tremendous change in the way we do computing. And we realize that getting used to the lazy computing is a bit harder. Okay, so that's why we decided to take this course in TensorFlow instead of using any other library, and that's why we dedicate more than a session, around 2 sessions, to TensorFlow, learning the foundations of it. Afterwards, we cover the foundation of neural networks, and then we will be understanding how exactly a deep neural network work. By the way, how do we train it, and what goes underneath it. Then then we start with convolutional neural network, whereby we will learn how to do it. We will learn a particular technique specifically designed for visual analytics work or visual prediction or visual um, identification of objects and so on. So that we'll be learning as part of convolutional neural network, and that's basically a very prevalent neural network. Then we learn about recurrent neural network. Recurrent neural network is another architecture of neural network specifically designed for the cases where there is a sequence where the sequence data is in certain sequence, such as stock prices. All right. And then we will be learning about autoencoders. Autoencoders have basically changed the way we look at language translation and so on. So we will be learning the mechanics. We will be learning the underlying theory, underlying philosophy, as well as we'll be doing practical application around all of this. The eighth one is reinforcement learning. Reinforcement learning is something where basically you are in an environment, and or your bot is in an environment and it has to take actions based on the environmental conditions. So we'll be building a kind of a tiny bot in the software, and we will be training it to balance things, to play tiny games, and we will be training it and we'll make it learn the games. Okay, so those are the parts of the course. The course is designed for everyone, just that this course is deep dive. In this course, we basically go into coding, into maths whenever needed. All right. But we also keep the practical applications at the same time. So it has all the three parts: understanding of the concept using practical applications, the coding part, how to really do it, and then understanding the maths behind it, what is going underneath. All right. So whatever is required to get the complete understanding, we have designed the course in that way. All right. So, all right, let's get started. I hope this course is useful for you, for all of you. Um, all right, a bit about me. I'm Sandeep Giri. I graduated long back from IIT Roorkee, and afterwards, most of my career I've worked on large scale computing. And I started my career at D. E. Shaw. Those who know about D. E. Shaw would basically understand that D. E. Shaw, from the beginning, was a very data and intelligence heavy company. And as a trivia, at D. E. Shaw, Jeff Bezos, who was the founder of Amazon, worked at D. E. Shaw. That was his first and last company to work at. And at Disha, we had a 10,000 node cluster in 2002. Okay, and there I had a very good exposure to handling all kinds of data for various kinds of predictions. All right. Next is after Disha, I founded a company called Tbits Global, where we managed large-scale documents. Afterwards, I joined in Mobi, and there I worked into machine learning, and I worked into doing the building a recommendation engine on 200 terabyte data. Afterwards, I worked at Amazon. Amazon's detail page is something that I worked on, and that's the mobile version is the one that I built. Mobile version of the detail page, not the entire Amazon, of the detail page is what I worked on. All right. So at the heart, I'm a software engineer and I enjoy explaining technologies to people and everyone. And that's why we started CloudX Lab. At CloudX Lab, we are doing all kinds of innovations in the fields of education and also in the fields of in the field of machine learning and big data. All right. So that's about us at CloudX Lab. Now, as we so if you are trying to get started with free lab, you can basically open cloudxlab.com. If you're already enrolled, go to step 5, right? Click on my lab and so on. Otherwise, click on start free lab, okay, and complete the process of enrollment. You might have to sign up using credit card or college ID and college email ID here, and credit card as in there'll be a $1 transaction that would revert back. Okay, so that you can right away start with Jupyter. All right, so okay, so let's understand deep learning, the real use case. Okay, let's get started. Now here is how many of you have played Mario? Yes, I see hands. Okay, so there are 7 hands. Okay, 11 hands. How many of you played Mario? Okay, I can see 29 hands raised. Wow. So looks like everybody has played Mario. Great, great. Now, my next question is, next question is how much time did you win the princess? How many of you actually won the princess? Wow, 19 people. And Sam says that he um, won the princess 5 times. All right. Wow. So great, great. So looks like quite a few. Now, my next question to all of you is, did anyone teach you? No, right? Nobody taught you. You can reply using chat. That'll be easy. On the Q&A, I have to uh, correct. So nobody taught you to play Mario. Now, n- my question is, my question is, uh, can it be automated? Can it be automated? Do you think do you think the way you learned Mario, can the computer also learn Mario in the same way by hit and trial, by keep trying and keep trying to maximize the goal, observing the screen and trying to maximize the goal? Can the computer learn that? Exactly like you. Can the computer learn in the same way, the way you learned Mario? All right, let me show you. Let me show you. Okay? And so what was done was basically, if you are interested to play Mario even today, you can actually hook an emulator, and load your Mario game in the emulator on the computer, and then you can play Mario in that. So that's what was done, and that's why that's what was done. So so the emulator was run inside the computer, and the another program was basically sending the keyboard command to the emulator. All right. So that's what was done. So basically, the program learns to play Mario, observes the game, and presses the keys by the way of emulator or simulator, and then it maximizes score. So a person named Tom7, he is a researcher. He did it first, and it became quite popular. And all program did was observe the software, which is emulator, observe its memory, which stores the score, and software keep and it the program also observes this screen and keeps on pressing the keys and learns what keys, what key combination or what previous screen and the key combination leads to greater score. All right, so that's what it figured out. Let's take a look. Okay, let's take a look. So in the beginning, on the day zero, program was basically the bot was basically pressing the keys randomly, going nowhere, and Mario dies of old age. After one day, on the day two, the program is more like a toddler. It's a little better. You can see it's a bit better. It's able to see, it is able to move, but it is not able to perform greatly. Okay. After a few more weeks of learning, now it seems to play pretty well. You can see that. It seems to play pretty well, and right? And this is where, so this is where the intelligence comes into play. So it kept on playing again and again and kept on learning. Do you think it will cross it? Wonderful. All right. So you can see that it is having no problem at all, and it is able to learn really well. And few more weeks of learning, and Mario is expert at Mario now. Now you are going to see something amazing. You're going to see that it exploits a bug in Mario. See that? What was that? What was that? The Goomba is falling on it, and it start moving slowly down, and it basically hits the Goomba. Okay, so it's able to dodge the Goomba. So it figured out the bug in the game, and you will see it exploiting another bug now. See, it basically, for somehow it figured out how not to fall. Okay, it figured out how not to fall that we have no clue about. The another game that it tried to play was the other game it tried to play was Tetris. Okay, so it basically tried to play Tetris, and when it could not succeed, it kept on pausing it. It kept on it kept on pausing the game when it could not succeed, and that's more like our behavior when we were a kid. That if we could not play a game at carom or any other game, we will just spoil the game and move ahead, right? Like remember the siblings or the cousins who will pause the game when they could not win it. All right, so it kept on. So these are couple of signs of intelligence. Okay, so great. Yash says that not to fall was available long back. It was not a bug, it was improved version. Great. This I wasn't aware of. All right. So what we just saw was that the program was able to able to play Mario better than us. Better than us. We never realized that we could dodge Goombas. Goombas is in the one that fall on you and you die. That's we never knew that we could dodge those. We could basically even score when they fall on you. So this is the amazing part of machine learning, that we were able to do things which we did not know. Okay, so had we programmed Had we programmed, we would never have found these jewels. We would have never found these secrets. Have we? And it will be more inefficient than ourselves. All right. So that's the amazing part of machine learning. Okay, amazing part of machine learning, that you could do things which you yourself don't know. All right. So and that's exactly the cases where you use machine learning instead of coding. Imagine you had to code a bot to play Mario. You'll first define gravity. You'll first define gravity. You will define collision. You will try to define objects, and so on and so forth. And it'll take a long time to actually come up with a solution. And still, that solution will be very limited, right? And next is, if we have to, next, that's actually a question. Now, so the program learned to play Mario and the other games without any need of programming. That's exactly the idea behind machine learning. This is the simplest example that I I want to That's the simplest example I want to give to explain what machine learning is. So the program learned to play Mario and the other game without any programming. Now my question to all of you is, you can reply using the chat. To make this program learn any other such game, such as Pac-Man, do we have to write new rules as per the game, or just hook it to new game and let it play for a while? Yes? Answer is true. We hook it to the new game and we let it play for a while. Yes, let it play like a child and hook it to the new game. Great set of answers. So basically, that's the amazing part of machine learning. We basically do not do not write the code and try to understand. Basically, we do not try to codify our understanding of the problem exactly. Instead, we try to see that how we can correlate the input and output, and how we can achieve the greater efficiency at doing the prediction without really coding. Okay, so that's the idea about machine learning. So the only thing we might have to change is basically the place where it's storing the score and so on. All right. So I hope this is clear to all so far. Now imagine doing the same thing for life, gather data, and solve problems automatically. You'll be amazed at the places that the same machine learning could be used are infinite. All right, are infinite. So lately I have been uh, uh, discussing or helping the various researchers or various entrepreneurs solve their problems using machine learning. Say for example, laying out fabric on a cloth in the image is one such problem that we worked on. The other one is in the field of crystals, where we are trying to see the crystal strength and so on. So there are many more use cases which we can't really uh, you know which are far beyond what we just saw. Okay, so imagine doing the same thing for life, gather the data and try to solve problems automatically. All right, that's the idea. And some of the things that which take the front page of the newspaper are these deep learning examples, and we call that Tsunami. Okay, like self-driving cars on the road, Netflix movie recommendation. There was a $1 million challenge long back that basically pushed machine learning to the forefront. All right, and the Amazon product recommendation was one such example. The search results are another. So these are the examples which are there out there, which you see it every day. And speech recognition by your smartphone. So all of this involve deep learning or machine learning mm, at a very at a very large scale. So what we need to do is gather data and automatically solve problems. So data with intelligence. In case of Mario, we were able to gather the data by playing it again and again and observe it again and again. So that's how the Mario worked. There was data and there was intelligence. Okay. All right. With respect to data, we need to do collect, clean, and process. And if the data is really humongous, like in our case at InMobi, it was 200 terabyte. So we had to first collect, as in store, and then do the cleaning, and then do the further processing and give the predictions. So to collect, we might have phones, devices, and we might require phones, devices, and connectivity. Also, in other words, all of these steps that we are talking about with respect to data collecting, cleaning, and process, all of it has become really, really good as of now. For collecting, we have phone devices. As of today, your phone has more sensors and is more powerful than the supercomputers of 1900s. Okay, and connectivity, as of today, we have Wi-Fi, 4G, NFC, GPS, Bluetooth, and so on. You have all sorts of connectivity to transmit data from the sensor to a central place. So data you need to collect and then do the cleaning and processing. Cleaning and processing is generally the same steps, but okay, generally the same steps, but they sometimes are also in two parts. So for cleaning or processing, we need, when we have humongous data, today we have distributed computing. And what is distributed computing? Distributed computing is groups of networks, groups of computers solving a single problem. Okay, and that's basically single problem, as in a problem being divided to be done on multiple computers. All right. So, all right. Further, there is a term called parallel computing. So both of these, distributed as well as parallel, both of these have become really, really powerful. And the parallel computing, as we talk about, has multiple processors and a single memory. And there has been a great amount of improvements. Okay, so when we talk about, all right, let me go back and explain from here. So so the to achieve greater results, we need good data, we need intelligence. For data, we need to collect, clean, and process. To collect, we need sensors and the connectivity. And to process, we need parallel computing. Parallel computing is of two kinds in general. One is distributed as in getting the work done on multiple computers. And the second kind is using the multiple processors on the same computer, right? So again, there are two kinds here. One is normal dual core, quad core, the kind of computers that you have been using. Other is GPU or general purpose GPU. So these are the basic kinds of parallel computing. So in case your program is complex and it takes a long time to process the data, you might require GPGPU or simply GPU. GPUs have many processors on the same board talking to each other and again communicating via the memory. And that's used in the deep learning at a very high scale. All right. So a question from Ravi is, what is the difference between distributed computing and parallel computing? So parallel computing is a general term in which we want to get work done using many units parallelly. So parallel computing is of two kinds. One is called distributed, other is called multi-core, and third one, it's basically three kinds mostly. Third one is called GPGPU. All right. So, all right, a question from Yash is, could you please speed up? All right, so that's a good point. So, yeah. All right, next question from Yash is, search recommendations, how does it show up if there is a new site and is really informative? So you can always correlate and you can always do predictions even if there's a new site. So I could answer it in detail the way we do it at Amazon or in case of InMobi. I can answer it in more details. Come over to the forum and I would love to answer this question. Okay, so great. Let's get back to where we were. So we were talking about the processing part. When we talk about processing part, we might require a distributed computing, or we might require a GPU in order to do the computing. Both of these are part of parallel computing. Now, a common question that I keep getting is that when do we use the multi-core? When do we use GPU? When do we use distributed? Okay, GPUs has hundreds of cores and they are really powerful. Just that they do not have very huge memory and are not great for bigger data. They're great for complex processing, but not great for big data, right? And they are great for mathematical computing, while distributed computing is basically a bunch of computers in the network. Okay, so they are great for bigger data, where transmitting data or loading data is not an option, where there we take the code, run it near the data. So when it comes to handling big data, we generally go for distributed, really huge data like few terabytes or more than few terabytes. When it when it want when in the problems we require a faster communication between CPUs or computer processors, we either go for multi-core or GPUs. Multi-cores are usual computers. All of our laptops as of today are multi-cores. If you are doing something in machine learning or you're doing something in graphics, you might need GPU. Okay. And the tools that you require is, in case of multi-core, the tools which are compatible with these is, say, for multi-core, anything can run, right? Like even normal scikit-learn or other tools can run. While in case of GPU, these are the tools that basically take advantage of GPU. In case of distributed, you would either require Hadoop, Spark, or TensorFlow. Okay. Now let's talk about the traditional versus deep learning approach. Traditional versus machine learning or deep learning approach. Okay. A question from Jay is, what is the data size limit for GPU? So GPUs come in around 8 gigabyte or 12 gigabyte of RAM. And the other limitation that you will see is the data is still read from the same kind of machines, same kind of disks, and therefore they are still limited by the hard disk or solid state drive from which they are reading data. Okay, good question, great set of questions. Please keep the questions coming, and I love to answer in more details. Okay. All right, so let's get started with our difference between the traditional versus deep learning. Okay. Most of you might find this session a little too basic, and the reason is that we always start introduction from the basics, and instead of alienating everyone, we want to keep things basic and then gradually increase. Okay. A question from Kanan. Spark comes up in three columns: multi-core, GPU, and distributed. Is it best then? Very good question, Kanan. So here in this that we have here is that Spark comes in all the three. So here the only downside is that Spark is experimental when it comes to GPU. They're not doing that great with GPU. So far, TensorFlow is doing, actually, we should put TensorFlow in distributed as well. Okay, TensorFlow wasn't there in distributed earlier. It wasn't that stable, but now they are becoming stable. All right. A question from Rio is, good question again. Question from Rio is that, is a GPU always needed for training a model? Okay, good question. So quick answer is no. Most of the work that we will learn as here, you can comfortably do it using a normal processor without GPU. Most of the training works pretty good without GPU, and just that it takes a bit more time or some more time, and okay. All right, it takes a bit more time, and therefore going for GPU makes it faster. All right. All right. A question from Yash is, the update in Q&A is, the question is answered. Is it audio-based ML? Because it shows up immediately, you respond with our name. So actually, there's a button to select a particular question, and then and basically I select the question and mark it done. That's how it works. All right, so yes, I'm not a machine learning robot. I'm a real person trying to answer your questions. All right, but I would love to see that happening in future, that we can't distinguish. All right, all right. So you can ask me Turing test just to make sure that I'm a real person. Okay, great. Now let's go ahead and let's understand the difference between approaches. Okay, let's understand the difference between a machine learning approach to problem solving versus a normal problem solving. Okay, imagine that you had to write a spam filter. Imagine that you had to write a spam filter like the one that you see in Gmail. In Gmail, you have spams and you want to filter some of the spams and so on, right? So, and you give in the historical record of emails that these are spams, these are not spam, right? Now, question is, how do you build such a spam filter? Okay, so first of all, this is the kind of approach that we did always. We had first we studied the problem, then we created rules like these if-else conditions, and then we evaluate the result. In case there are errors, we go back and study the problem again, and then create new set of rules. Okay, these are the rules. We used to call it business rules. Okay, and there were quite a few systems to help us write these rules in a friendly way. Now, once we evaluate, and then we can either launch or go back and study the problem again. And once the errors are good, we launch it. Now, question to you is, do you see any problems with this traditional approach? Do you see any problems with this traditional approach? Yes? Please answer using the chat. Okay. And what are the problems that you see? Yes, great set of answers. Constantly having to study the problem. If a new case comes in and it's time consuming, it uh, uh, depends on how programmers are giving the rules. Yes, someone has to manually decide. Correct. So rules need to be rewritten. Yes, yes. And evaluation can be hard. Yes, wonderful, wonderful set of answers. Okay, so please answer the questions. I may not be able to read every answer, but it is really important to get involved. Yes, rules might require alterations. Any other thing that you foresee? The problem with this traditional approach. The problem with this traditional approach. Yes. It requires an domain expert. Good. Yes. The the rules need to be constantly revisited. Why? Because yes. Why? Because 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 what if the spammers know about our rules? If spammers figure out that these are the keywords that are being banned, so let's not use the keywords, right? So problem is not trivial. Yes, spammers can adapt. So problem is not trivial. Problem will likely become, first of all, there'll be huge complex list of rules, will be very hard to maintain. And then if spammers notice that you are blocking all the emails with for you, and then they might start writing for you, or the spammers might use personal type emails or some new ways to escape. That's right. So essentially the basically spammers will keep working around your spam filters, and you will need to keep writing new rules. And that's exactly the problem with the traditional approach, right? So all right. So the ML approach is that you study the problem, you take a look at the problem, and then you structure it in the form of machine learning. Then you train your ML algorithm on that structure of the problem, and then you basically feed the data, train your ML algorithm, and once you have trained it, then you evaluate it and see how well it's doing on the past data and past unseen data, and then analyze the errors. If the errors are beyond what you were expecting, you go back and review the problem again, train the ML algorithms again, and then once the evaluation is successful, you're happy with the evaluation, you launch. All right. So this is a big difference in the approach. All right. A good question. I would love to answer this. Answer a very good question from Yash. Question is actually both the questions are part of the same. Question is, how are the new cases handled in this kind of classification using ML? What if new unknown set of spam occurs? A good question. Question is that our model will able to classify the things which it has seen in the past. That's right. But there are two ways to classifying things. One way is instance based, as in there is something coming in and we basically compare that with our existing past history, and whichever instance it is matching, whichever email it is matching, we say that we know about it. That's called instance based learning. The other learning is the model based learning, in which given a humongous data, we come up with a proper model with all kinds of headers, footers, the subject line, the keywords, considering everything considering all of the criteria of an email, we come up with a model. Model is something where even if we do not have seen an instance in the past, we can still do the prediction as long as the model is stable and the model's boundary is very clear. I'll show you this part. And 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 of course, our machine learning algorithm would not be able to handle the things which are drastically different from what we have learned in past. And that's correct, because that's what we want, that our model should be able to do the predictions which is similar to our past historical data, right? All right. I hope I was able to answer the question, but that's a very, very hard thing to do. That unknown set, as in if it's completely different, if the new emails are completely different, the format is changed, everything, then it's difficult to categorize. But if you have taken into consideration all kinds of parameters, the chances are that coming up with completely new set of email is going to be hard for a spammer. All right, great question, and I'm sure that others would be having a similar question. And all right, I hope I was able to answer your question. So a question from Srinivasan is, hope modeling in ML is also a continuous learning. Yes, that's the next thing which we are coming up with. Okay. And yes, that's what where we are coming to. Wonderful, wonderful. A question from Helman is, this seems like a supervised learning classifier problem. Does deep learning encompass this, or is deep learning a separate separate ML? All right. Good point. Good point. And this is something that could be useful. This question could be useful to all of you. It's an very important question. So it is a supervised learning problem. Yes, it is a supervised learning problem. What is supervised learning? We are going to go into it quickly. So in supervised machine learning problem, we have input data and we have target and target variable. So we have data with which we can teach an algorithm. So this is our input, this is our expected output, and so on. So those kind of problems are called supervised machine learning problems. We're going to go into details again. Now, the question is, does deep learning encompass this? So what is deep learning? Deep learning is basically the a technique of machine learning. It's a part of machine learning. Most of the problems, supervised, unsupervised, can be solved using these newer techniques. So you can think of it as a newer algorithm. All right. Instead of thinking it as something that is not machine learning, it is part of machine learning. Deep learning is part of machine learning, and in under deep learning, we have better set of algorithm, specifically multi-layer neural networks. All right. Another very good question is categorizing the scene data, isn't it overfit? So here, what we are doing in this problem particularly is we're studying the problem, feeding the data to ML algorithm, and then we are trying to evaluate, right? We are trying to evaluate. Now, if we evaluate our results, our algorithm on the same data on which we trained it, then it will do a very good job, right? If it is doing very good job on the scene data and not doing on the not doing good on unseen data, in that case, we basically are overfitting. It's basically memorizing everything. Correct? So what we do generally is we'll go into more details, and I think we'll include something called end-to-end project first. We're going to change the flow a bit of machine learning. We're going to include end-to-end project first, and then we will go into individual technique. All right. So now coming back to it, here what you see is before we train the data, that's basically something that we have not shown here. Ideally, what we do here is this data that you see is broken into two parts. One part randomly selected called test data. Other part is training data. So using the part which is training data, we train the ML algorithm, do the prediction and evaluation based on the testing data, so that it doesn't memorize and it doesn't try to recall instead of predicting. Okay, so will basically have to do this in most of the machine learning algorithms. Good question. All right. So continuing to Yes's question, isn't manual intervention still required to tell ML that there are new keywords or criteria? You can always build the pipeline and let the pipeline pu pull in more data and do that. Okay. A question further is machine learning and deep learning are subset of artificial intelligence? That's right. So AI is basically doing things like human, and that's what we're going to discuss. Okay. And yes, and I think I need to move a little faster because all of these questions will be answered as we go forward. All right, great, you're right. So question from Howard is that so does that reduce model biases? Yes, it does reduce both model biases as well as the overfit. We'll go into more details about it. All right. Great, great. Wonderful, wonderful set of questions. And these questions are really important. And I would love to answer them in more details. Okay, great. So spam filter, based on machine learning techniques, automatically learns which keywords, which phrases are good for predictors of spam by detecting the unusually frequent patterns of words and so on. The program will be much shorter, easier to maintain, most likely more accurate than any of the traditional approaches. So we can also further make it automated by the way of making it the whole process of updating the model and updating the data can be made automated in the sense that in the sense that as and when new data is coming, we will basically where the new data is coming, we'll basically retrain the model and launch, keep on pushing it to the production. All right, unlike traditional approaches, deep learning techniques or machine learning techniques automatically notice that for you has been unusually frequent in spam flagged by the users, and it starts flagging them without our intervention. All right, and question is, can machine learning be helpful for the humans? Answer is yes, in many ways. It can help us learn deep learning algorithms, learn various aspects of the email that we can inspect what they have learned, what algorithm has learned. Spam filters after enough training could reveal combination of words that it believes are best predictors of spam, may reveal unsuspected correlations or a new trend. It could lead to better understanding of the problems for human. Right? It can basically augment our understanding of the problem. It can augment our understanding of the problem. Okay. A question from Nikhil is, ANN is overfit model that is high bias and low variance. So, all right. So basically, those who are aware about machine learning, I would like to take a bit of digression here. So in most of the algorithms, we basically try to reduce the bias and improve the variance, as in reduce the bias as well as the variance. So we call it trading bias for the variance. Okay, so ANN basically is performing really great with respect to lowering the bias as well as low, keeping the variance low. All right. So so essentially, most of the deep learning techniques are around lowering down the bias. Okay, and variance is a good problem to solve by the way of various techniques. So first attempt with whether deep learning or neural network, we try to reduce bias. All right. We will talk about these in more details and how do we exactly achieve low variance and low bias by the way of neural algorithms and so on. We will go into more details. All right. A question from Ravi with ML, do we need to loop at the bottom? I think this is what you were talking about. Right? Correct. So yes, once we are very confident about our machine learning technique, and we have built our mechanisms to protect against unseen cases, we could create a loop. All right. All right. So that was a very quick understanding of what is machine learning and so on. Now, there are many algorithms, many techniques to do the prediction. Given the data, we try to predict the outcome. There are simple ways like drawing a line, that's called regression. And there are complex, a little bit more complex called decision trees and so on. All right. One such technique is artificial neural network. These are the computer systems or computing systems inspired by biological neural network that constitute animal brains. All right. So basically, the neural network is nothing but a piece of software, or you can say the program or the algorithm, which essentially the artificial neural network is essentially piece of program or a software that that is inspired by the animal brain. Okay, and that basically learns from the past and and predicts something, predicts, it starts giving the prediction. Okay, so that's basically the ANN. I like to further give you more definition and then explain how it works. So ANN, or artificial neural network, learn progressively improve the performance to do tasks by considering examples. Okay, so it generally without task specific programming, we don't need to do task specific programming. We generally just need to build these models. Okay, say for example, we want to classify an image whether it's of dog or a cat. Or let's say we have an image and we have a set of images. We know that which ones are having cat and which ones are not having cat. Let's say we want to build such a model. We want to learn that part. So that can be very well done with ANN. Okay. Now, how does it work? All right. How does it work? So the animal brain is made up of something called neurons, and neurons are connected to each other. Okay, neurons are connected to each other. Each neuron is a very simple unit. Each neuron gets signals from one end as an input, and it gives out a signal as output. So the way you can think of a neuron is it basically accepts inputs and gives out output. The interesting part about neuron is that each neuron contains something called a weight, something called a weight, and the weight keeps on changing. The easiest example to do is that when you go to take bath, you have two two knobs on the left, and you can say two input flows to your tap. This is your tap. There is a hot water. There is a cold water. Now, what you generally do is you turn on the tap, and you change the knob. And let's say you start from the middle, you check the water. If it is too hot, then you go towards the cold side. If it is too cold, you go to the hot side, right? Now, the only difference is there is a slighter difference between how the neural network is trained and this example. In this example, we knew that the cold is on the right side, right? But in the real case, we don't know which of these parameters are impacting our outcome in what way. So what we do is we figure out each neuron, we basically tweak these weights and observe that changing the knob to the right is increasing the temperature, or changing the knob to the left is decreasing the temperature. Okay, so we first figure out that which side is cold and hot and so on. So that's basically the gradient descent, we call it. And so essentially, each neuron that you think of in an animal brain not only does the prediction, but also learns the weight. Okay, this is my expected output, and these are the inputs. Now, tweak the knob such that the expected output is achieved by tweaking the knob, and by changing the ratio of cold water and hot water. Okay, so I hope this example is clear to you, that there are two inputs to our knob, and we are tweaking the neuron. This is where the algorithm comes into play, that we basically tweak the knob such that our output is right. And the way we do is there are multiple algorithms that tweak it. There are multiple variations of even the gradient descent algorithm, that what we do is we start from the middle. We first observe that changing it to the right is increasing the temperature, decreasing. If so, is it equal to our expected water temperature? If no, then we change it to the other side, and we keep on doing that. All right. So we basically minimize this error by tweaking the knob, by changing the knob's position. Right? This is what happens at each individual neuron level in case of artificial neural network. All right. Do you want me to explain it again if it's not clear? All right. So essentially, it's just like everyday routine. We go to the bathroom and we turn on the tap, and we have cold water, hot water, and then what we do is we imagine that we don't know whether changing the knob to the left or to the right is basically giving us hot water or cold water. Now, so we keep on tweaking the knob in a very smarter fashion, and that smarter fashion is called gradient descent algorithm. We first figure out that we slightly tweak the temperature knob to the left and then observe that what happened to our outcome. If it became colder, then go to the other side. If it is becoming hotter, to that side. So we basically tweak the knob, tweak the each neuron in order to achieve the right temperature, right outcome. The outcome, no, we are not looking for coldest water, we are not looking for hottest water. We are we are we looking for the right temperature for us, and we don't have a thermometer. We don't have a thermometer, and we don't know the temperature of the hot water and cold water, so that we can just mix them and do the calculation. That was the traditional approach was that find out how much is the flow from left, how much from the right, and what is the relationship between the knob, and so on. So if the temperature of this one is x1, this is y1, and the flow is this much, we sum it up and then we do the calculation. That was the traditional way. The newer way is just like human does, just like we do, that we tweak the knob in order to get the outcome. So this hot water, there could be hundreds of such parameters, and this could be like a good experience, good bathroom experience, right? We want to maximize the flow and we want to have best experience. So these could, as the number of neurons grow, when the number of neurons basically when the number of inputs grow, you need to increase the number of neurons. And further, let's say these are the inputs, these are the, this is where you're receiving the inputs, and then you can also put more neurons after the neurons, more knobs after the knobs, and you can think of them as the greater layer by layer, and these are the knobs which have been layered. Okay, so to solve complex problems, you can keep on adding more and more knobs and achieve better complexity, can solve more complex problems where there is hot water, cold water, and there could be more and more such parameters. Like the other parameter could be who came in. The third parameter could be what was the environmental temperature, that in summers we need different temperature water, and in cold days we need different temperature water. So there could be 4 5 different kind of inputs, like who is the person and so on. Right now, in those cases we will have to layer knobs by knobs, and this is where the deep neural network comes into play. This was the simple neural network, and this is deep learning neural network, or we call it simply deep neural network. This is where you are going to measure whether the outcome is going great or not. This is where the input is coming, and you have put so many knobs in between. Okay, can number of neurons be uh, increased to get almost perfect result? Yes. So that's what we do. We basically first, the hypothesis was long back that let's increase the number of neurons in one layer, and number of neurons, that was in the beginning, that we basically increased number of neurons in the first layer. But later on, people figured out that if we lay it in this manner, they are giving better results, they're giving more precise results. And trust me, there is no clear explanation that why multi-layer gives better result than the single layer. It's just the only intuition that this one takes care of non-linearity in the input. Okay. A question, very good question from Jay. Can ANN be called as trial and error method? Can, let me just select this question. Can ANN be called as trial and error method? So there is a bit of difference between trial and error. Okay. In trial and error, basically we do kind of a bisection. We we check if the output is, in case of trial and error, we kind of know which side is the input value. Here, it is sort of trial and error, honestly. It is sort of trial and error if you take a look at, say, the underlying algorithm called backpropagation or gradient descent. Now, it's sort of a trial and error because there what we do is we check whether output is good or not. If not, we basically go and change the weights in the different direction. If it has increased, we go and change it to decreasing and so on. So it's sort of a trial and error, but a little more sophisticated than the usual trial and error. Okay. Now here there is when there are multi layers of neural networks here there are when there are multiple knobs and the layer of knobs is really complex, then tweaking the weights becomes a little more tricky. Okay. So what we do is we basically we call it like partial differentiation and you call it like backpropagation. But let me try to take a good analogy and try to explain in very simple words. Okay, let me give it a shot. And so we start from here. We tweak one of the knobs and observe the change in the outcome because of one of the knobs. Or there are so many other knobs. So what we do is we basically observe the change because of one of the knobs by doing the partial differentiation, and and that's exactly what happens. Okay. So we have to iterate over so many knobs. We have to iterate over so many knobs. And as and when we are adding more and more knobs, the complexity is multiplying. It's not adding, it's multiplying. And therefore, we require really powerful computers in order to tweak so many knobs. Okay? Very good set of questions. Let me answer these few more questions, and I think that will be quite useful for all of you. So because our sessions are very question answer intensive, this is the only session where we have, I'm spending less time in answering because it's a bigger session. And in our usual session, there are 20 people, and we basically kind of discuss in details. All right. So let me. The point I was trying to make is that we should get used to um, questions from other people in the session. All right. A question from Ankit is, do we put different set of input data on different layers, like weather conditions? Good question. Good question. So what we do is we here, this is where the input comes. Okay. So the point that you're saying is here, the body temperature, the water temperature, weather conditions, everything comes in the input layer. This is the input layer. And these are all weights. These are all knobs that you need to tweak in order to achieve the best output. All right. So the output of, let's say, the output of this neuron is going to all of these. The output of this neuron is going to all of these. This output is going to all of these, and so on. Right. So point from Harvard is, or maybe it's intuitive understanding. Yes, kind of intuitive understanding. And let me. Okay. I think it was continuation of some other discussion. In case there's a question, please feel free to ask again. I'm really sorry. I missed the context. Question from Naveen is that in the right diagram, shouldn't there be a connection between all of the top nodes in the hidden layer? In the right diagram, okay, shouldn't there be a connection between all of the top nodes in the hidden layer? Okay, these ones, all right. Yeah, it should be there. That's right. You're right. Thank you. So yeah, yeah, that's kind of in the design we miss these ones as well. Okay. So yeah, there has to be a connection there between these. All right. Uh, yeah, that's a good point. Okay. A question further is that what are these knobs? Let me just explain again. So I was saying that each neuron is like a knob that you tweak, and in order to get the best water temperature. Okay. And then when we say best for you. Okay. In the same way, in the same way, here, if we basically have many inputs, so we'll basically put, these are the inputs coming in. So we'll put so many knobs and we'll tweak all these knobs in order to achieve the right temperature, right? So this could be your hot water, this could be your cold water, this could be the environmental conditions. So this water is actually becoming like information when it comes to the machine learning, right? And so on. So it could be like the geographical location, the climatic conditions, the person, probably male or female, or the hot water, how much is the hot water on the left hand side, how much the cold water, and so on. So these could be the input variables, and these are the various knobs which we are tweaking in order to achieve the good temperature. Now here there are multiple outputs. Here there are multiple outputs. Ideally there should have been, in our case there will be only one output called the yes or no, whether the temperature was yes or no. But in this case there could be multiple outputs, in the sense that you're looking for multiple predictions or multiple labels or multiple values. Okay, so so this is basically an example of a simple neural network, and people figured out that in case this input is not right, very simple, it's not like linear. Had it been linear, you could just draw it on a graph paper and could figure out that for these inputs, this is the output, for this input, this is the output, and this is the correlation. If it was simple, you could generally do the regression by plotting it on a graph paper, or on a chart paper. So but if it's really complex, then you require these neural network kind of models whereby we could solve complex problems. Now people figured out that a single layer wasn't solving uh, great problems, so they kept on adding more and more layers. The output of this one, when instead of going to the here, it went to another layer, and that's what become. Okay. All right, so there are very wonderful questions, and I would love to answer these questions. A question from Robin is, in some actual use case, how does tools such as TensorFlow tweak the neuron and add multiply a neuron? Is it only automatic, and how? So that's exactly what the algorithms like TensorFlow do. We write the code. Okay, TensorFlow is just one way of programming. You can actually do the same thing using your Java code, C code, Python code, Perl code, PHP code, and achieve the same results. The TensorFlow is just an optimized version of the same. TensorFlow allows us to do kind of algebraic computations instead of doing the calculation immediately. It lets you create a graph of graph of statements. We'll go into more details and you will get the idea. So TensorFlow isn't doing much of a magic. Is Sorry, TensorFlow isn't the only way to do any of these computation, you can actually write in any programming language. Just that TensorFlow, number one, they made it really fast and efficient to do all kinds of such calculations. Second, they made the things, they wrote common algorithms and made it available as part of TensorFlow library. Okay, so those are the things that TensorFlow did. All right. And we will go into more details about what is the gradient, all of these, how exactly these weights are tweaked, how exactly we achieve the outcome that we are looking for. We're going to go into more details, and that would give you more confidence. All right. Yash, was I able to answer your question? This particular question? Okay. All right, there are a few more questions. Let me answer those questions. These are really important questions, and all of those, I mean, everyone could be benefited by the questions, and you should also try to answer these questions. A question from Ravi is, just posted this question in the chat, but wasn't sure if it was looked at. Actually, I'm not able to look at the chat. I'm mostly focused on Q&A window, and in this hot water, cold water knob example, can you illustrate what constitute the parameters, what constitutes the weight, and what constitutes the attributes? Good point. So in the hot water, cold water, and knob example, the inputs were the temperatures of hot water and the cold water, and the knob was weight. Okay, knob was something called weight that we tweak in order to achieve the outcome. The parameters that you say, uh, essentially the parameters or input parameters are the temperature of the hot water, temperature of the cold water. Okay, so that's what it was. All right, so input parameters are the left and the right, then the flow of the input and so on. Okay, so essentially, what we are trying to do is, why did I take this analogy is that in machine learning, what we have is inputs, weights, and the output, right? In our example, we have inputs. And in machine learning, inputs are also called input parameters because there could be hundreds of dimensions and so on. All right. I hope I was able to answer the question. Quick question is, how do we determine the hidden layer? My quick answer is it's mostly hidden trial, but the general intuition is that in case the problem is complex, we go for more layers, and if the problem is simple, we go for less layers. All right. Yes, but there's no straight answer. And if you look at the entire history of the neural networks, you'll find that there is no straight answer to it. It's mostly hidden trial. Okay. A question from Ankit is, the inputs are given by a programmer. What if we miss some situations? The inputs are given, yes. The inputs are given by us. Inputs in the sense that we provide the historical data, historical input, like historical input, and then we basically learn from that historical input. Okay. Even if we miss some situations, most of the algorithms are ready to do the fill-in and take care of the missing data. Okay, missing situations, because we are not looking for exact match. We are looking for approximate match. Okay, a question from Tanmay is, some of the ML algorithms perform better than DL. There could be, yes, in some circumstances when the normal algorithm do perform better than DL. Okay, even a simple regression, sometimes the linear regression actually performs better than deep learning. All right. Good question. A question from Sam is there a criteria on to choose which knob to tweak, or is it on the random basis? Okay, so essentially there's an entire maths around it. So what we do is we go from left to right and then right to left. Okay, so we start from the left and start just uh, calculating the value on the right. So we take this, we assume the random weights. We basically, initial states of the knobs, we basically put it in the midway somewhere randomly. And then we go from left and keep on computing the value for the right. And once we reach the right, then we start going backwards and keep on observing that which knob, which tweaking of which knob is causing the changes here. Okay. And that's what we do. All right. That's called backpropagation. A question from Robin is, so can the tweaking of neurons also be manual in other cases? The tweaking of neurons, uh, yes, you can actually try that out, but it's going to be very, very time consuming. But the tweaking of neuron is essentially the automated way. That's the reason why that's the reason we call it machine learning, because machine is the one who tweaks the neurons or change their weights. Okay, and so on. All right. Question from Prakash is, what is the perceptron model and how it works? So honestly, this simple neural network is what we call a perceptron model, like this. And we'll go into a historical way, but briefly for now, we could think of perceptron model like this, a simple neural network and without many layers. Okay. Question from Yash is, hidden layers I did not get. So this is the input, correct? This is where you are feeding in the input data. This is the expected output. And this is called a hidden layer. Hidden layer is what that matters because that's what they contains, the weights. Okay. So in multi-layers, these are all hidden layers. All right. Okay, what do they do? What do they work? Basically, hidden layers is nothing but the various knobs that or weights that we need to tweak, our algorithm need to tweak in order to come up with such a model that when we feed the data here, our outcome should be just perfect. Okay, in all offline cases such as when the server contains the automation program is down during power outage, is it possible to manually acquire data from cache and manually tweak the neurons? A very good question, very good question. So these weights that you see, right? These weights that you see is something that we are trying to come up with. We are continuously tweaking these knobs, changing these weights in order to match our expected outputs, correct? In case in midway, there's a power outage, or let's say I want to send it to my friend that, hey, I've trained till this point. Can you carry on from this? Yes. So the libraries like TensorFlow and others, they can basically utilize this. And also very important side effect of the question, it's a very important question. So the other thing could be that imagine that I had really high-end servers. So what I'll do is I will train the neural network, find out these weights, and hand it over to you. And then, hey, I have already trained. You can just use it, right? It's like once we have tweaked the knob and we are okay with it, then we can take bath, right? Then we don't need to tweak the weights. Okay. Similarly, that's called using the pre-trained models. Okay, using the pre-trained models. All right. Okay, so what are the knobs physically in the computing? They are basically number. They are basically variables. Each knob is just a number, and these are called when you have list of knobs, these are a list of numbers, and therefore they're arrays. And now arrays of arrays becomes a matrix, and that's why the maths come into play. All right. Okay, it's a single machine in the same memory. This is what is happening. So these weights are nothing but nothing but the numbers, the decimal numbers. Okay, varying from 0 to 1, and generally 0 to 1, and then this is called array of numbers, and then there'll be array of numbers, and so on. Okay, so that's what is called NumPy array. We generally use that. Okay. A question is, oh, I selected the wrong question. These are wonderful questions, so let me just try to answer them, and then yeah, we will basically go into more and more details as we go ahead in the course, and we would also go into more practical. Right now, I'm not able to show you a practical example of how neural network is actually learning, but we will do it uh, in more details. Question is, how do these neural nodes learn the inputs? Okay, as I told you that they don't learn. We basically write the logic in such a way that we tweak the knob, observe the output, and then see what's going on. Okay, they are basically the nodes don't have any. In our model, the way we have built the artificial neural network, the weights, these nodes are just the weights, nothing else. Our algorithm from outside does the tweaking of these weights. All right, but that could be an interesting model whereby there is a functional unit at every point and is doing doing the calculation just like real neurons do. Okay. All right. Question from Yash is, I'm in math in the hidden layer. Yes, yes. So basically, these are basically list of numbers, and the algorithm is the one that is basically going to tweak each of these values from outside. Okay. And for math, I can take a separate session because the attendees have a different expectation. They're looking for more introduction than the mathematics behind it. I can actually take a separate session on that. A question from Sudarshan is that this might be irrelevant. I heard about some fields involved in initial days of machine learning derivation. What are those some fields in the initial days of machine learning derivation? Yeah, so in the initial days, it was basically the perceptron models, and those perceptron models is what people used to use, and they thought that they are dead, they are not useful, until people realized that you could create layers. Earlier, people were trying to just increase the number of neurons, and they realized that it's basically normally like it's not giving great outputs. So they came up with the idea that let's put them layer by layer so that inputs of one goes to another. The output of one is input to another. That became the breakthrough. A question from Rohit is, can we feed seasonality to help knobs to get better output? Can we feed seasonality? If let's say we get seasonality, we will just basically make one more input parameters. We will make it one more parameter, and that, okay. So as in when we can increase any number of, here we can keep on increasing any number of inputs. Basically, that's another neuron. We'll put it here, and more and more input features come into play, or input attributes come into play. We'll keep on increasing this layer, and hence this, and or if this we are using this one, so this is the input layer here. We'll keep on add one more thing called seasonality, and we'll feed one record at a time, observe the output, another record, observe the output, and that's what we do. Okay. Great set of questions. The only thing is that the subject is a bit complex, so it might I might assume that you know this or know that, so will take me a bit of time to figure out what is right for the audience. Okay. A question from Anonymous is the output of the whole system determined by an algorithm which monitors the entire flow of the decision from layer to layer, or is it going to be based on the decisions of the knob? Okay, so knobs are basically unintelligent. Knobs are basically numbers. It's the algorithm. What it does is it goes from left to right in the flow and keeps on changing the knob, and then it keeps on observing whether the output has changed or not. So your first assumption is right. Okay. Question from Yash is, let us say we developed a model, but each person might have different settings. So do we really just deploy as a person assistant then rather than common for all? Mhm, Let me try to see. Okay, I think it's or should I take a break here? All right, after this question, we'll take a break. Break for 10 minutes after this. Question is, let's say we develop this model, but each person might have different settings. Correct. Good question. So question from Yas is, let's say we developed a neural network model which is doing good for one particular person, but there are different persons in the house who also take bath, right? We basically, let's say we developed a model for one particular person. Okay. We developed a model for one particular person and it's doing pretty good. Now we might have different persons, and different persons could be having different settings, right? And that's exactly the point here, is that we basically, let's say we add one more neuron here, okay, and we basically have these weights. Now these weights will be such that they will consider who is the person, okay, who is the person automatically. Okay, so these weights automatically will be tuned such that based on, if we feed one more we create one more input neuron. This is our input neuron. We create one more for, say, person, let's say yes, or right, yes, his brother. So this contains like those two flags. Now the weights will be automatically tuned such that it will start giving prediction for yes and yes is brother. All right, so that's the idea. That's the idea. Good question again. I'm very happy that it's making you able to think about those aspects. Okay, so as in when we are increasing more and more input parameters, we might have to increase these layers of knobs and so on. Okay. All right. A question from Nikhil is, you have 4 by 4 by 4 hidden layer, that's right, but it can be set of numbers in the hidden layer. Yes. So you saying that we could have more number of layers? We could have 4 by 5 by 6 by 7, right? Yes, we could have any number. We could experiment, and there are certain patterns or intuition that people have built that around neural network. They basically figured out that if we keep equal number of neurons, that generally gives a better output. Earlier, they were trying funnel based that will create the funnel kind of models. People have tried all sorts of different variants, and you'll be amazed at all kinds of architectures that there are there right now. You can just use them out of the box and they just perform very great. A question from Helman is, a question from Prakash is, all right, what is the role of bias? How does it affect the neuron? Bias is something really complex. I can answer it probably later. Okay, so uh, the bias is something, you know, ignoring we doesn't learn the complete idea. So I think I can go into the details of bias probably at a later point of time. Okay, because bias and overfit underfit is a bit more involved. Okay. uh, all right, great. Let's take a break for 10 minutes. All right, so hi everyone, I'm back. Should we start now? You can answer using chat. You can answer the questions using chat, and you can ask questions using Q&A window. All right. Uh, Solomon, you have raised a hand. You can ask a question. Are you not able to hear? It will not be possible to unmute anyone today because there are more than 100, more than 115 people in the session. So it'll be better to ask questions using the chat. Wonderful set of questions. Keep asking question and also try to look at the questions of the others, and that would help you also to be ready with better explanations and better understanding. All right. So next question is from Hellman. Does the machine learning algo determine how many hidden layers are required or the amount of nodes determined by the programmer? Good question. Good question. So we basically call it something called a grid search. So what we do is in a for loop, in a permutation, we'll just write as a code that add one more layer, add five more neurons and try the output. If the output is great, basically we do the cross validation, we do the analysis, automated checking of the outcome, how far are we from the actual temperature is all of that. We basically in a big for loop, what we do is we feed the data, train the neural network, then we observe how well the neural network is doing, and then we compare whether one layer is good, two layers are good, 10 layers are good. Okay, so we do that. So we basically that one is kind of, we call it brute force because it'll try all possibilities. We'll try with one layer, then two layer, then three layer, and so on. And then we will also try to increase the number of neurons in each layer, and then we come up with that. So that one is a little bit more like a brute force. Okay, so it's done by programmer in the sense that by the way of coding instead of manually, and sometimes we do that manually also. Okay, a question from Sudarshan is okay regarding hop. Okay, that was yeah. So okay, a question from Robin is what URLs for the deep learning related math. Okay, so the best one I find is the deeplearning.ai. I find that website really good and it's quite useful because there's a book called deeplearning.net or deeplearning.ai, and it's actually a pretty good book. You can use that one. It has everything that it requires. Okay, it's from Joshua Benji and others. A question from Yash is, can we also get back what important? Okay, a question from Yash further is that can we also get back what are important inputs? So later we can reduce inputs and sensors in the model. Okay. A question is when we are let's say here we have inputted like 50 different data points. Sorry, 50 different attributes for each data point. Let's say there are 50 input data points. 50 input attributes that we are feeding to the neural network. Now, question is, can we also, in a way, derive what are the important features, what are the important characteristics of the data, instead of focusing on all of the columns or all of the input features or the characteristics of the data? We basically will only focus on those particular columns. Okay, good point, good point. So basically, you will get an idea here based on what feature weights do you get. If these weights are almost like zero, then you can ignore these. All right, but in neural network, finding the importance of the feature becomes little tricky and difficult when there are multiple layers. Okay, when there are multiple layers. So, okay, and all right. All right. But your usual way of reducing dimensions, reducing the input columns, or reducing input features remains the same. The standard way of reducing dimensions will remain the same. Okay, you can use that one. Or these algorithms, I'm just wondering, like, because in neural network, there is no straight way of figuring out the importance of each feature, each input. All right. Simple neural network, yes, it's pretty straightforward, but deep neural network, it's hard. Okay. A question from Ankit is, as the feature increases, input nodes increase, right? Yes, as more and more complex input comes in, generally we increase. Generally, yeah, we basically increase input number of nodes as the features increase, correct? If there are 50 features, there'll be 50 input nodes. That's straight, okay? And question is, can the number of layers and weights be optimized for a given set of, can the number of layers and weights be optimized for given set of inputs and output? Yes, that's exactly the purpose of most of the machine learning projects. Okay. And we basically make sure that we are not kind of memorizing by testing again and again. Okay, keeping the testing data and training data separate. Question from Srinivas is, for more precision, continuous learning of this model is required, like based on outside climate condition, what shall be controlled by neurons and still more conditions. For more precision, continuous learning of this model is required, like based on, yes, yes, that's correct. A question from Ankit is, if in the historical data we didn't have the input, right? Then do we manually fill in an unseen input? So we don't, a general perception is that we need to have all instances in the input, right? But here, it's kind of linear, it's kind of, you can think of it like a regression, because even if we have not seen an input, we can do the prediction based on the model, based on these knobs, okay? Based on these knobs. So that's basically the idea about machine learning, that even if you don't not have seen input, you can basically use those conditions to predict the output. Okay, so we don't really have to fill in an unseen input. Okay. Question from Yash is, also could you please speed up rather than answering question? I hope if right, don't worry about the covering everything, because how good is something covered which if it is not well understood? All right, so we will be able to cover, don't worry, we'll be able to cover the topics, so you don't. All right. A question from Robin is that I find your DL presentation very helpful. Yes, all of you will get the link to the presentation, and yeah, you will all get the recordings also. No worries. A question from somebody is, what is backpropagation? Backpropagation is this technique whereby the way I described to you, the way we were computing each neuron, by tweaking the weights, checking the output, tweaking the weights and checking the output, that process is called gradient descent. Here, what we do is we start from the left and we assume the value of the weights or these knobs, and then let each of them do the calculation at every point. We basically do some multiply this input water temperature with the knob, and then we do the computation, and we keep on doing that till the point we reach here. When we reach here, we compare how well are we doing with respect to the actual output. Okay, once we reach here, we compare that, oh, we are doing pretty bad, then we go back and tweak these, and then tweak these, then tweak these, and then tweak these. So basically we start to do the back propagation. Okay, So when you have multi-layers, then you need to do backpropagation in order to figure out which weights are best for you. Okay, we'll go into exact mechanics of it in more details in the third chapter. Okay, in the chapter number 3, that is training the models. Okay, a question from Naveen is, does a pattern emerge regarding the number of layers and the performance of the chapter, the performance of the system? If so, would it be possible to minimize that function to get best model for the problem? Question is, does a pattern emerge? Yes. So that's again a very interesting question. And that's kind of difficult because a lot of work is going on in the interpretation of the models. Okay, because deep learning, when this comes to multiple layers, it's more or less like magic. It just works in many cases. So figuring out that what does this particular layer is doing is actually hard. So we basically have one of the discussions around it in which we figure out what does it mean by a particular layer. The way you can think of each layer as that each layer is introducing a complexity. This one is doing basic shapes, then the next one is doing shapes of shapes, and that way. It basically, the complexity of the model, non-linearity of the model is represented by the layers. If your data is not that complex, then you don't need neural network. All right. Question from Ankit is, if in the historical data, if we do not have input, do we manually fill in? No need to fill in. All right. We don't need to fill in all the historical data. There is only, if there are a particular cell that is missing, you can fill in with the median value of the column. But if there is a no record, my question is, why do you want to fill in an unseen input? Okay, there's no need to fill in. If a particular cell, a particular value for a whole record is missing, in those cases, maybe you can think of filling it using the median of the whole column. All right. And I can go into more details about that. If you come over to our website, there is a forum. You can ask questions there. All right. You can ask questions on the forum. Question from Prakash is, how is feature engineering done in deep learning? In deep learning, we generally don't do feature learning. Instead, we make the feature engineering is like combining multiple input variables into two, or something like that. So that was quite popular earlier in the classic machine learning, but in deep learning, we generally don't do the feature engineering. That's one of the reasons why it is more popular. Okay, while the fundamentals that we had learned in machine learning, the remaining fundamentals remain the same. Okay, a question is, can we use deep learning or random forest for variable importance and then plug those in ANN? Um, so deep learning is ANN, right? So can we use random forest? Yeah, you can use random forest for variable importance, and then you can plug it in the ANN. Yes, you can do that. Okay, that should be okay, but you generally leave it to the neural network to figure out the importance, and that's kind of okay. A question from Prakash is, does deep learning is to low dimensional feature space, or what is the threshold of number of feature space when deep learning should be used? All right, all right, good question. Question is, how many minimum number of input layer neurons should be there, right? And if the input is not that complex, should we use it? Yes, we should use it. In many cases, we do. And you will see that in case of recurrent neural network, in case our input data and the output data have really complex relationship, in those cases, the deep learning could be very useful in inferring that relationship, even if the number of variables are lower. Okay. Question from Pankaj is, how to prepare training set for the model? Yeah. So The principles remain same as machine learning. We will go into more details about this as part of the remaining session. All right, we will learn how to prepare the data and so on. Okay, remaining as in from chapter 3. I would like to understand more regarding the portion of the process training the data. Please cite more example. So we'll be training on the data, and if you have gone through our end-to-end project, you will get the picture from there. Okay. So yes. All right. And all right. Question is, I would like to understand more regarding the portion of the process training the data. Please cite more examples. As in training on the data, right? Training the model. Training the model as in we will be discussing in more detail very soon. All right. Okay. A question from Nikhil is, can we use algorithms like the, yeah, that we have answered. Okay. All right. Please take relevant questions on the to the slides and proceed. All right. We'll do that. Okay. All right. Howard, could you complete the question? I kind of missed the context. Okay. Uh, a question from Clement is, when CA we use deep learning neural network. What is CA in case of okay, when can we use the deep learning neural network? Okay, when can we use the deep learning neural network? So basically, deep learning neural network is used in the underlying algorithm behind most of the systems that you see today, whether speech or whether translation, whether in the underhood, like word embedding, the NLP, the natural language processing, it's the neural network that is used. Okay, the same mechanism what we discussed today. All right. So yes, great. So we have taken quite a few questions, and let me just close some of the more questions. Can you explain deep learning types beside ANN? There are quite a few. Okay, which amongst these algorithms used by? Question is, can you explain deep learning types beside ANN? All right. So deep learning basically is any, as in, to be very honest, deep learning as a term again is overly crowded. It is started as purely deep neural network with multi-layer, but as of today, almost everything is deep learning. Okay, people have come up with more types, so I'm not going to go into that part. All right, because what is most important is to understand that how do we take our problem, utilize the deep neural network and solve it there. All right. So as of today, deep learning people, I mean, even in the normal systems, people are using the deep learning as a word. Okay. So we will stay focused on our definition, which is the one where we talk about neural networks. Okay. And the term deep learning is being used interchangeably with the machine learning as of today. Okay. A question from Manjit is, which amongst these algorithms are used by IBM Watson? I think all of them. Okay. Okay. Now moving ahead. So if no historical data should not fit, if no historical data, should not manually data fill, just drop the missing. Yes, so it depends. Like in case your input record, there are only a couple of values missing. In those cases, you can. A question from Harvard is that if, let's say, there is a particular row in which the data is missing, should we manually fill it or drop the missing data set? All right. So you can. It's completely okay to even take the median of the whole column, fill the value median or mean, whichever looks good. Just use that value to fill in those missing cells. But if your record is completely missing, a lot of data is actually missing, then you should generally drop the record instead of causing anomaly. Okay, so that's all. If a particular record doesn't have enough amount of features. But again, there is no right or wrong answer. In this case, you generally do the cross validation and figure out whether it's good or not. Okay. All right. Sure. Let's take a question after a while. So let's just move ahead. Okay. All right. So moving ahead. So there are many companies which are using the deep learning, and the deep learning is being used by everyone. Whether it's BuzzFeed, Airbnb, Optimizely, Google, Facebook, and Pinterest. And mostly a machine learning project is a combination of usual techniques combined with the neural networks. Okay, so, and even Google Translate, earlier it was using the classic machine learning, and now they have moved on to the neural networks, and it is doing pretty good. And this was one of the demos. Okay, so all right, let me just show you. This will be a quicker way of taking a look at it. All right, so let's see if I could make it full screen. All right, so you can see that these are the inputs. X1 and X2 are the inputs. Okay, and here, although the definition of input in the real sense is not like this, instead, the X1 or X2 is going to be uh, the dimensions of individual inputs. Okay, this X at any point of time will be one of the data points having X is this, Y is this. So that's what it is going to be. Okay, so there are these two kind of data points. Okay, this and this, let's say. Okay, now we are feeding this kind of data. Okay, and what we want to do is we want to say figure out the boundary, the model which separates the two. Okay, which separates the two, and this color is only for us. The color is not for the model. Color is not visible to the model. It's just for us. So imagine that our data is like this, right? Our data is like this. Now we want to find out the boundary which separates them well, so that when we come up with the new data point, we should be able to say that it's in the inner boundary or the outer. All right. So here these are the number of hidden layer neurons, and this is the outcome neuron. So if we run it, it's going to try to figure out. It's basically trying to figure out the 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 way to divide the data such that the misclassified items are in a separate boundary. So it is trying to figure out the boundary between these two data sets. Okay, so if we increase the neurons and uh, okay, so let's say we are okay. So if we increase the neurons, the chances are that it would figure out the boundary. Okay. All right. So we can bring in the non-linearity by adding more dimensions to it. All right. So you can see that it is able to figure out that there is a circle dividing the two data sets. All right. This is just one example. All right. So one thing I would like to discuss is one thing that seems to be coming up again and again. Okay, let me just pause it. So this is one such example which you can try. Okay, let me open the chat and share it with all of you. Okay, let me walk you through. There's a question that is coming up again and again related to the algorithms. So I'll just go ahead and answer the question related to the types of machine learning. Just give me a second. Let me pull the presentation, and we'll just walk you through quickly through the types of machine learning. I hope that helps. Looks like another question is, does TensorFlow need a license? No, TensorFlow is open source and free to use. All right, let me walk you through the kinds of machine learning and types of machine learning, and I hope that will help you understand the difference between supervised, unsupervised, and so on. Okay. All right. Let me just walk you through the examples of like classification of the machine learning algorithms. Let me take out the slide. I'm just locating the slide in which I had. All right. So I'm just going to walk you through the basics of classification. All right. And then I think most of your questions are around it. So that should be okay. All right. I'll just walk you through in 5 minutes. I think that'll be good. All right. So though it's kind of something that I had not planned, but I'll just walk you through quickly with the normal terms. Okay. So let's just walk through it, and all right. So a common question that keeps coming is what is AI? AI is basically the intelligence shown by the machines. Okay. So the AI means the intelligence exhibited by the machines. It is theory and development of computer systems to perform the task requiring human intelligence, such as visual, speech, and decision making, and so on. So it has been it has been quite an old fantasy to achieve it. Okay, and right. Okay, so the term. All right. I'll prefer that if we don't uh, post the promotions here and there. All right, never mind. So, okay, so AI essentially was basically has been a computer science branch for quite some time. In 1956, they the term artificial intelligence was coined by John McCarthy, and the proper definition was given by the whole team at the workshop. And basically, these five things: perception, reasoning, navigation, and NLP, along with representing knowledge, are the sub-objectives of AI. AI is essentially the it's a definition, it's an objective, it's not a technology, it's an objective. Therefore, when I say it's an AI system, it means that it seems to behave like animals or people, right? When we say that. And uh, it starts with representing knowledge. We have tried all kinds of things. And out of all of that, the systems that are being built now with word embedding and the natural language systems are far more better than the older way of representing knowledge. Then the second one is reasoning. Reasoning is another sub-objectives of AI, being able to play a complex game like chess, Go, or Mario, and prove geometric theorems and diagnose diseases. That's reasoning. Navigation, how do we plan and navigate the real world? So that's again, being able to move around is another sub-objectives of AI. NLP, as in natural language processing, is another sub-objective where the computer should be able to understand the language. Yes, I'll be sharing this slide as well. Now, the next one is the perception. How do we see the things in the real world from like sound, touch, smell, or like heat and so on. So that's perception. The generalized intelligence is another very interesting idea. Generalized intelligence is basically the intelligence like sixth sense or intuition. Okay, so as per the John McCarthy and team, what they came up with is that if we are able to achieve if we are able to achieve the basic basic characteristics, basic sub-objectives of AI, then the generalized intelligence would emerge. Generalized intelligence is like emotional intelligence, creativity, reasoning, and intuition. If you look at the Mario that we played today, the Mario game, you will realize that in that game, we kind of saw that the bot has an intuition around playing the game, right? So that's basically that would emerge if the previous building blocks or previous sub-objectives are met. All right. Now, the artificial intelligence is basically uh, some part of the AI is robotics, some part of is rule-based systems and domain-specific computing, and say machine learning was like core part of the AI, and deep learning is further one of the tools to solve machine learning problems, and so on. Okay, so I hope this diagram is clear to all. All right, now moving ahead quickly to the machine learning kinds. Machine learning can be categorized based on whether supervision is required or not. Second criteria is whether to learn incrementally or not. Third one is how it generalizes. So these are three ways of of categorizing the machine learning. The first one is based on human supervision, whether it requires supervised data or not. In that case, first one is supervised, second one is unsupervised, and third one is reinforcement. So supervised is something where whether or not the models are trained with human supervision, and supervised is further divided into classification and regression. Classification is where we are trying to label the data. We are trying to classify something into one label versus another. Okay, like spam or not is a classification problem. Regression is predicting the value, like you have an old car and you want to predict its value based on other similar cars in the industry. or other cars, the value of other cars available. Based on that, you want to predict the value. Okay, that's called regression. Regression is predicting a decimal number. It is hard to differentiate between classification and regression in number of cases, right? Like hand-drawn characters, if you are trying to predict whether it's 1 or 9, it generally you will think that it's a regression, but it's actually a classification problem. Okay, so right? So we talked briefly about this. So what we do is, in case of regression, we basically try out all possibilities instead of trying all the lines that go through the direction. Let's say we are trying to figure out which line will go through these data points. So instead of trying all possible lines, what we do is we go in the direction that's yielding better. All right. So that's basically the gradient descent. We will go into more details later. Now, the second kind of machine learning is unsupervised, where the training data is unlabeled. We have no supervised, no teacher is available. System tries to learn without a teacher, such as clustering. Such as clustering. Imagine that you're given data and you have to form the clusters out of the data, and you're not told that you are only told that the data could be classified using this definition of distance. Okay, you're not given exactly what each cluster represents. Okay, so in those cases, when you are trying to group similar visitors to your blog, that is clustering. Okay, so clustering is detect number of groups in your blog, and basically there could be many examples of clustering when you want to bring various items together based on certain definition of the distance, that we call clustering. To train the model, we just feed the training set to the clustering algorithm. At no point we tell the algorithm which group belongs to which label, which visitor belongs to which group. Okay, so clustering is a part of clustering is unsupervised learning, and classification is supervised learning. In classification, we have clear definition of a label. We compare that this record belongs to this particular label. Should this record belongs to the same label or different label? That's basically the classification. And in clustering, we don't have a clear definition of a group. Nobody has told us that this is the label for this group. We just given the data and asked that draw the boundary such that we split the data into clusters. Okay, draw the boundary that brings the similar items together. This is clustering. All right. So in clustering, it may notice that 40% of the visitors are comic lovers and read the blogs in evening. 20% visitors are sci-fi lovers and read the blogs during weekend. So when we cluster, we could come up with these interesting observations. Okay. There's another kind of clustering called hierarchical clustering. Hierarchical clustering is giving the data, break them into a tree, convert them into a tree. Like, for example, what biologists have done in case of hierarchy of evolution, like right, human and chimp belong together and so on. So basically, this is hierarchical clustering, given the details of all the species, coming up with a chart is called hierarchical clustering. Okay, it's basically in the form of tree. Nodes that are closer to each other are similar. Question from Prachi is, in classification we know rules, and in clustering it predicts groups. Correct. In classification we are given the label that classify these items into these labels. Okay. Other examples of unsupervised learning could be detecting unusual credit card and transactions to prevent fraud. The third one is reinforcement learning. Reinforcement learning is a very interesting example because it kind of belongs to supervised learning. but it's a little different from supervised learning um, because of the way it happens. So the example that we took today related to Mario, the example that we took today related to Mario, playing Mario and so on, that's reinforcement learning. We are learning based on the environmental conditions. Okay, so essentially we keep on learning. In the next step, the past history of the data right now is not relevant. The current input is the my learning and my current environment, and then we take the action. So basically the reinforcement learning is very prevalent when it comes to the game. So mostly the reinforcement learning is in the form that there is agent, there is environment. The agent observes, selects option using a policy, takes action, and get reward or penalty. So this kind of learning is called reinforcement learning. All right. A very good question is decision tree is supervised or unsupervised. Decision tree is basically a algorithm, or you can say the model, which can classify the items which are similar together. So decision tree can be used in both. It can be used, the decision tree is used in both supervised as well as unsupervised. Very good question. All right, I'll be answering questions very shortly. Okay, so the learning system as an agent in this uh, essentially observes the environment, selects the options, and moves ahead. Okay, there are many applications of reinforcement learning. It's used by robots to learn to walk, and it's used by deep learning's AlphaGo, in which the world champion, AlphaGo defeated world champion Lee Sedol at the game of Go. Okay, so that was reinforcement learning. Further, the other way we can look at learning is in the whether we are learning incrementally or we are learning batch wise. Okay, meaning let's say there is a server on which continuous data is coming. One way is that we do the learning once in a while and deploy the model. The other is we, as in when new data is coming in, we are learning from it. That's learning incrementally. Okay, so batch-wise learning is we are given data, we feed the data to algorithm, and we let it go. The okay, in case of online learning, we keep on the system keeps on learning as and when new data arrives. Okay, so the system incrementally learn, and as and when more and more sequential data is coming in. Okay, so you can use online learning for huge data set and can be used, and basically the data that is not fitting on one machine can be used. We can learn from that in a incremental learning model, as in when that basically if you have a billion records and you want to learn from it, the normal algorithm will look at the whole data and then try to load it and try to solve it, which is may not be always possible. Therefore, in such cases, we generally go for the algorithms which are online learning kind of algorithms, because they can just look at a couple of records. All right, so the only downside of online learning is gradually the system's performance keep on declining, because if the bad data is fed to the system, and bad data can come from malfunctioning sensor or robots and someone spamming your system. All right, challenges in online learning is that you will have to closely monitor the system. All right, the third one is an important aspect. This is something that we have is coming up again and again in the Q&A. The third kind is how well do they generalize? Okay, there could be instance-based machine learning or model-based machine learning. Imagine that this is the kind of scenario, and we have triangles and squares, and we are trying to predict whether something is a triangle or a square. So in the instance-based learning, what we have is we have labeled all the elements that this is a triangle, this is a square. Okay. Now, when a new instance comes in, we see that which one it is closer to. And we see that, okay, this is more closer to the triangles because there are two triangles nearby and there's only one square. Therefore, it must be a triangle. This is called instance-based learning. In such systems can only predict the cases which are sort of already seen and are not really stable. They are not really stable. While while and also such systems end up memorizing. They basically learn by heart instead of coming up with a model. They keep on memorizing. Okay, so spam filter flags emails which are identical to known emails. This could be one example of instance-based learning. Also, the emails which are similar to known spams, right? Basically, it measures the similarity, and based on similarity, it says that whether the emails are similar or not, and so on. This is called instance-based learning. While the model-based learning is something where we figure out a model. Like here, we figured out that, okay, there is a line that divides this data and this data, right? So such models are very efficient. For example, if new instance comes in here, it will be classified as a triangle, not a square. Okay, while instance-based learning, this will be classified as a square. These model-based learning are very efficient because here, if you think about it, the model is what? Model is this line, okay, not all the points. While in case of instance-based learning, it has to keep everything in the memory and iterate. So instance-based learning are slow, consume more memory, while model-based learning are faster because they just have to check against the model. And models are generally smaller than the actual data. Therefore, the models are faster than the model-based learning is faster and less intensive than the instance-based learning. All right. So, all right. So this is basically the classification of the machine learning. All right. This is the part that I wanted to avoid today. I thought that this will be okay to avoid it. All right. So yeah, let me now take up the questions. I hope this is good enough for you. And then I'll also talk about a few more things. Now, there are many deep learning frameworks available as of today. There are TensorFlow, Theanos, Keras, Caffe, and Torch. So we're going to go with we're going to go with TensorFlow in this course. TensorFlow, why? Because TensorFlow is something that gives you a more complete detailed picture rather than only parts of it. Also, TensorFlow is well supported, and it is going to become, it is anyway most popular and is being well supported by well-funded teams. Okay, so we're going ahead with TensorFlow. But if you are able to go through TensorFlow, you'll be able to easily use any of these libraries very quickly. So the objective is not about a language, not about a framework, but the objective of the course is to learn deep learning. Okay, not exactly, we are not bound. If let's say you learn in TensorFlow, that doesn't mean that you would not be able to do using Keras or Caffe or Torch or Theanos. All right. So that was about frameworks. Now, the other machine learning frameworks, the usual ones, are scikit-learn and pandas. These are simple frameworks. Scikit-learn has probably the most exhaustive library which you can use, and pandas is a way of loading things in a tabular structure using Python. We will also touch upon briefly in MLlib, where we talk about in case the data is really humongous, which cannot fit on one machine. In those cases, you generally go for systems like Spark MLlib. Okay, if your data is too much or it's taking too much time, you generally divide it on multiple machines by the way of either TensorFlow distributed or using MLlib. Okay, so you can take a look at our machine learning specialization course or our deep learning course. And okay, so now let me answer the questions that will be useful to you. Okay, so you can go to cloudxlab.com and go to, since the deep learning, this is a deep learning course, most of you have already taken. There are a couple of seats available. If you're interested, you can join in. Let me answer the questions after this. All right, so you can take a look at the course, and right. So here you will see the syllabus, the learning path. So here the learning path is this. There'll be a few more additions to this. The few more additions that I have planned is uh, one, I'm going to do natural language processing in a bit more details. We will do a brief MLlib example, and we will also do time series and unsupervised learning as part of this. All right. So we're going to, I mean, even though it covers only the basic part, these all of these all of these topics will be covered. Plus, we'll be adding more details. More we'll be covering more topics such as unsupervised learning, the time series, and the MLA. Okay, so we'll basically do one example of each, and that should be good. Now, moving ahead. Okay. A question is, I'm a .NET developer with 6 years experience. Do I have a scope in machine learning? Will it be possible for me to switch career to machine learning and AI? And how do we start? It's a very common question. And my answer is that learn the machine learning, right? The reason is that you can apply machine learning in whichever domain you are. Okay, in whichever domain you are, you can definitely apply machine learning. All right. I can see that happening already, and this is one of the biggest challenge happening because um, people who are from non-technical background, non-technology background, or people who are not in, hardcore computing, they think that it's the technology is of no use to them, or the machine learning is no use to them, and that's one of the reasons why they are not able to solve their problem better. All right. So I would recommend everyone to basically give machine learning a shot, whether with us or anywhere else, doesn't matter. So what is more important is that to understand that whichever work you are doing, whichever kind of computing you're doing, you should be comfortable with machine learning because machine learning is impacting every aspect. Like for example, if you even take a look at say this presentation, right? And there is something called insert symbol. Okay, I'll just show you. And does it have? Or maybe the Google Docs would have. All right, for a minute, I'll just pause the screen. And so you'll be amazed at knowing what kind of solutions are out there being developed for every domain, every vertical, whether legal, whether software design, whether framework design, everywhere, the predictions are playing a major role. As simple as this. Okay, I'll just show you. Let's say here, you see, insert special characters, correct? Insert special characters. Right now here, this is it used to be pretty simple, but what they came up with, you can draw a symbol. Let's say I draw an arrow, so it is giving me these suggestions. Okay, so once you know whether you are doing any kind of computing, you should be able to come up with these creative things, and that's what will change the way you look at a product or you look at an engineering. All right, so that's very important part. So almost every engineering is going to be impacted in more ways than you can't imagine. All right. So going back to our discussion, All right, that was one question. Now let me answer the second question. Question is from BMD. Question is, can we have Q&A towards? Yes, that's what is happening. All right. Question from Nikhil is, suppose in case defaulter and non-defaulter problem, at the end we have only one output value. Defaulter and non-defaulter problem. Okay, okay. Yes, that's basically true and false, and that's essentially a binary classification. Is that the question? Yes, our question A point was most of them looks like some idea about ML instead of answering specific question. Can we? Yes. All right. So that's the reason why I went through the ML classification slides. Question from Yash is, can you explain anomaly detection using neural network? So good question. So autoencoders are used for the same. Okay, autoencoders are used for the same. In autoencoders in neural network, we basically feed the same data. For unsupervised learning, we use autoencoders. All right. A question from Ajay: How different is ML from the project planning software like MS Project and Primavera? ML is essentially the core of learning. It's used for prediction. It is used for uh, basically coming up with uh, building a tool which does help the user by showing the predictions, by giving the predictions, and so on. So project planning softwares like MS Project are good for doing a particular part. ML is not a project planning software. Okay. A basic question, real world data set, data does look like this. I mean, something that can be plotted on 2D, how to get input data into this format. A good question, Harish. Question is that whenever we talk about machine learning, we are just showing the chart and graph, and it looks like that the input data is only two-dimensional, and we want to plot it. The good part is that machine learning problems are inherently multidimensional. For example, if you even take the first example that we take in case of classification called MNIST, whereby we are trying to detect the handwriting, right? That one has how many dimensions? 784 dimensions. Okay, so instead of worrying about bringing everything into 2D, what you have to do is you have to see that is it really required. So if it is really required to bring data to 2D, what you do is you basically use any of the dimensionality reduction techniques such as PCA and force the data to come to two-dimensional. All right. So, but it's not really required to translate your data to 2D. Your data could have any dimensions as you wish. Okay? There's the most important part. Just that if the dimensions are more than 1,000, it generally becomes the memory starts overflowing and you're not able to take care. So in those cases, you basically reduce dimensions, remove the dimensions where there is no variation in the data, and you just keep the data or keep the dimensions where there is a variation. All right, that is PCA. You can take a look at the PCA. Question is, what does NLP means? NLP is natural language processing, like taking an English sentence, inferring the meaning of it, or taking any other language, human language, and inferring its meaning is called NLP. All right. A question is, what is RPA? RPA is robot process automation. That's a general term to do automation in the normal office work. Okay, some part of it may be machine learning, some part of it is basically interacting with websites, using a tool, and so on. Okay. Question from Ankit is, where does deep learning fit into all of these? Deep learning is an algorithm. You can say it's a kind of an algorithm which can be used in all these machine learning types. It can be used in it can be used in supervised, unsupervised, it can be used in incremental learning, it can be used in reinforcement learning, and so on. Okay. A question from Nikki is, do you have experience using MATLAB for deep learning? No. We use mostly TensorFlow, and I have not used MATLAB once, maybe around 15 years ago, long, long back. Question from Dharithri is that, hey Sandeep, I have just 4.5 years of experience, but I want to go to AI research area. What is your opinion about this? Without having a prior experience, is it good to switch to AI? Yes, why not? Why not? Since you have IT experience, you will know how to deal with data, the basic of data. You'll be knowing how to prepare data for machine learning, and then you will know the importance of coming up with the predictions. So your experience is definitely going to add value, and therefore it's completely okay to go for AI research area. All right. Uh, A question is, how successful is ML in the fields of stock analysis till date in your perspective? It's pretty successful, and yeah, it's pretty successful in able to predict doing the stock analysis. One of the projects that we'll be doing is on the same. All right. A question from Zakari is, deep learning can be worked as R as efficiently? Yes. So that war between languages is settled down. You can do everything from in every language. All right. And specifically because of TensorFlow kind of tools, whereby the core efficiency is in the TensorFlow engine, not in the Python or R. All right. So that's a very good reason why whether you do TensorFlow using R or TensorFlow using Python, the performance you're going to get is same. Because main computation is happening in TensorFlow, which is basically far more performant and is in C++. Okay. How can you arrive with the right function to be used in neural network? You mean right activation functions? Yes, so that will study in the training models, and we will be covering that part, that probably out of the whole discussion, generally the ReLU, ReLU is the one that is used mostly. All right. A question is, how will deep learning ML help in industry? For an example, please. There are many examples in almost every industry, everything the deep learning could help. All right. The examples are many, many, many. All right. In almost everything. Okay. Even in education, whatever we are doing as CloudX Lab, we are utilizing machine learning for our own work. Like for example, detecting whether a slide is in the video or not, detecting at what position the slide is found in the video, and taking the text and taking the voice and extracting the text out of it, or taking, let's say, a video and extracting the text out of it, as well as we have built something called auto quiz, which takes text and it takes a page and comes up with a quiz. So the ML or deep learning is going to disrupt the entire market, and it has already disrupted the entire market. Sooner or later, every company, every software is going to use it. And uh, it's not for now, but people had been trying a lot, a long back also, even as very small industry, which was a friend was running. So we were trying to do identification whether a printing firm is printing the labels very well or not. So for that, we were comparing a given label with a standard image, and then seeing whether how much of the color deterioration is there. So that time it wasn't successful much because of the complications in the algorithm, and therefore we kind of left it. But now if the same problem comes along, it can be solved by engineer with 2 years of experience or 1 year experience. So that's the kind of state we are in. In last 10, 15 years, there has been wonderful research in the industry, and the research is available for public, is available, unlike the olden times when the research was not available, it was kind of closed. As of today, almost every great tool is available for free. All right. It's only a matter of time, matter of learning. It's only a matter of applying. That's all. So ML deep learning is greatly going to change the way we look at the industry. It has already changed. Can you share us? Sure. The videos and slides will be shared with all. How to use deep learning or machine learning in industrial IoT. Okay. You can utilize it in many ways. In industrial IoT, you can do predictions of temperature and so on. And there are many more use cases. If you have time, drop me an email with your exact use case. I would walk you through a couple of more scenarios. All right. So drop us an email at reaches@cloudxlab if you want to know more, or come over to the discussion forum and we will walk you through the entire. I'll try to answer this question over discussion forum. All right. So we have a good discussion forum here at discuss.cloudxlab. All right. So because this question requires, all right, I think this webinar just wasted my time. Hope at least it helps with that. Yes, this for a lot of you, it might look like a waste of time because this one was aimed for people who are trying to get started with machine learning and deep learning. The next sessions from chapter 2 onwards are going to be more technical. And if you're interested, you can join in there. All right. A question from Daritri is, do you provide any practical AI or ML or NLP project session? Yes, we do. We do provide that. And it's all basically, we only keep it online. We don't have offline. All right. A question is, as automation ML seems to reduce human efforts and make systems work more smartly, are these terms can be used hand on hand in an organization? Okay. All right. Yes. So yes, it can be. It can be the ML and AI can be used to reduce the human efforts. Specifically, let's say using a tool like Selenium. You are testing your website and you want to detect whether the text is garbled on your screen or not. In those cases, you could basically utilize any of the machine learning technique, and there are many more ways in which the automation and ML can come together and be used. And probably many people are already using, probably Chrome is using for testing whether Chrome framework is rendering the website easily. Last time I came to know that they basically were crawling around 10,000 websites every day for automated testing their Chrome, and they were exactly uh, doing the similar thing. Okay, so definitely there are many ways in which Selenium and ML algorithms can work together. Your course covers deep learning with Spark. No, we will basically have a chapter called ML Lab, which where we'll be briefly talk about how to use ML Lib in your flow. Okay. A question from Nikhil is, we have approximately 9 modules and how can we connect every week? Yes. So, so every week at this same time on Saturday as well as Sunday, India time, 7 a.m. to 10 a.m., we'll be having these 3-hour session, and that's how it'll happen. Okay. it'll be the same Zoom webinar, just that instead of 100 people, it'll be lesser people. Okay. Can you please throw some light on the topics of AI, on robotics? And sure, we'll take it into consideration. And if you put it on the forum, I can answer it there. All right. Question from Alfred is on how many awareness can you integrate in your system? Like I understand that AlphaGo was not aware that it's playing the Go game. That's a really hard question, and I suggest that you take a look at the book like Shadows of Mind by Roger Penrose to get the idea about what it means by awareness and the consciousness. And it's a hard question. So come over to the discussion forum. I would love to answer it in more details. All right. A question is, how can we get data set? Is there any way to get data set easily if someone is not in this job? Okay. So, all right. So data sets are something very important. So you have to, it depends on what is it that you're trying to do. Is it a confidential data that you're trying to do the machine learning on? Then you can basically sign an uh, non-disclosure agreement with the company or with the individual, and then you can get the data set. Or you can, if you're trying to look for the public data set, you can take a look at the UCI, and there are quite a few data sets available. Okay. A question from Ravi is, will there be practical labs as part of this? Of course. The whole thing is practical except for today's session. Today's session was designed for larger audience, so we don't have too much of hands-on today. But you can actually go to CloudX Lab and take a look at the various topics that are available for free that you can attend right now. There are the Python course you can finish and do the hands-on by yourself. And in the lab, you can anyway do anything that you wish to do. All right. All right. So the lab for first 7 days is going to be free, but afterwards you will have to just pay for monthly, which is very, very tiny amount. All right. And I'm interested in applying ML in genomics data. Any topics or info on this? Yes. So most of the machine learning or deep learning is a generalized techniques, and therefore can be applied on all kinds of data. All right. It's just a uh, matter of structuring your data. Any trainings available on IoT or Industry 4? Right now, no, but we are planning something in there. All right. So great to have in the session. I look forward to see you. There are going to be more detailed hands-on sessions, and you can take a look at the learning path. So yeah. So we're going to go more detail into that. And all right, a question from someone is ML best way to use for identify and detect fashion attributes? Yes, it can be used. It can be used. All right, so great to have all of you in the session. I'm really happy that that so many great set of questions were asked, and I hope I was able to answer your questions. Though we had a lot of questions and we had a very limited time. Okay, if your question is unanswered and you want to get that answer, just please leave it on discussion forum at discuss.cloudxlab.com. We would love to answer. Also, there are few seats available for deep learning course. If you are interested, you can join. It's going to be very hands-on and a little bit more detailed session, very project-oriented course. All right. So thank you, everyone. Great to have all of you in the session. Thank you, Robin. I find the live webinar Intro to Deep Learning very helpful. I highly appreciate your addressing. All right. Thank you, Robin. I'm very happy that you like the session. All right. Great. Great. So I look forward to see you in the next session on Saturday after 6 days. Okay. A question from Devapriyo is, are the two tracks, machine learning and deep learning, can be done in parallel? Uh, yes, you can do that, because what I'm trying to do is there's only one chapter that I feel that should be included here. So I'm going to include probably the end-to-end project that will give you the entire understanding of the parts of machine learning which are useful here. Okay, so yeah, that's what we're going to include it here, so that we all get an idea about an end-to-end project, and then we'll go deep dive into every concept. All right, so great to have all of you in the session. I look forward to see you in the course. All right, you can enroll here on the URL which I've posted. All right, I'm hoping that the session was useful to all. Thank you, everyone. Thank you for spending 3 hours and great set of questions. Thank you, everyone. I look forward to see you in the next session. Bye-bye. Have a good day. You will all get the video and the slides. If you have shared your email ID, you will get the video and the slides. All right. In the next session, we are going to start with TensorFlow first, and then the machine learning. All right. A question from Jay is, any success story from the class? Um, Most of our students are pretty successful, and we just need to quantify that one. So, yes. All right, other two tracks can. So deep learning, you can do it because what I'm doing is whatever machine learning concepts are going to be required, we are going to include it here just after the up and running with TensorFlow. So even if you have not gone through the machine learning, you can still attend it. All right. Thank you, everyone. Bye bye. Have a good day.